All right, so the last part of this unit is 4.8, Complex Numbers, Part 2. So let's first talk about, the first important thing we're going to talk about is a conjugate. Okay, so conjugates are two pairs of binomials with identical terms but sharing opposite operations in the middle. So it's a binomial, which means it has two terms, but there's two sets of them, two pairs, or I should say one pair. And then the terms are identical, so the same, but the middle, in the middle, the operation is going to be switched. So like for this one, letter A, the conjugate of this one would be, the terms are the same, but the operation in the middle is switched. So those two are conjugates. Okay, let's do this one. The conjugate of this one would be 8 plus 4i. And the last one, this one kind of trips people up sometimes. The terms stay the same, so this one's still negative 3. And this is 2i, but in the middle it's a plus sign. Okay, so those are conjugates. So what's the big deal about conjugates? Well, let's see what happens whenever we multiply those conjugates up above together. So since they're both binomials, you have to distribute it out. Okay, so I'm going to distribute this 3 first, so that 3 times 3 would give me 9. 3 times negative 2i is negative 6i. Then go ahead and distribute that 2i, so 2i times 3 is positive 6i. 2i times negative 2i is negative 4i squared. Okay, so some things happen. Let's talk about it. If you notice, these two in the middle, negative 6i and 6i, when you add them together, they cancel each other out, which is sweet. And then the last term, negative 4i squared, well, we know I squared is negative 1, so this is like negative 4 times negative 1, which is positive 4. So now I have 9 plus 4, which is 13. So, as you notice, conjugates are a good way to get the imaginary numbers, or to get rid of them, okay, which we'll have to do a lot coming up. Okay, so let's do this one again just for the practice. So I have 8 minus 4i times 8 plus 4i. Let's go ahead and distribute. So this would be 64 plus 32i. Distribute the negative 4i, so this would be negative 32i minus 16i squared. Okay, and I'm going a little fast, so if you need to rewind the video, go ahead and do that and watch it again, but I'm going to keep going fast to save time for the video. So positive 32i and negative 32i cancel. Negative 16i squared, well, I squared is negative 1, so this becomes positive 16. So now I have 64 plus 16, what would that be? I think 80. Okay, last one. This one has a ton of negatives. Be careful. So I have negative 3 minus 2i times negative 3 plus 2i. So distribute. Negative 3 times negative 3 is positive 9. Negative 3 times positive 2i is negative 6i. Negative 2i times negative 3 is positive 6i, and negative 2i times positive 2i is negative 4i squared. Clean it up. The middle they cancel, and negative 4i squared becomes positive 4. So 9 plus 4 would give me 13. Cool. Okay, so now we're going to talk about how to simplify whenever they're dividing, or it looks like a fraction, which means dividing, with complex numbers. So you never leave an imaginary number in the denominator, okay? So no i's in the denominator ever. Don't do it. Because if you leave it in the denominator, it's not done. You need to keep going. So let's see, letter A, can I simplify this anyway? Well, 4 and I are not like terms. You can't divide them. There's not a whole lot you can do, but we need to get that I out of the denominator. So what do I need to do? Well, we need to multiply it by something, and remember, whatever you multiply the bottom by, you must multiply the top by. So what's the one thing that I could multiply that by to get rid of an I or change it to something that's not an I? Well, you can multiply it by I, right? Because this on the bottom would become I squared, and on top you would get 4I. Remember, I squared is -1, so you could write this as 4I over -1, which would be perfectly fine because there's no i's in the denominator. Or if on this one, if you want to write it as -4I, either answer would be acceptable. Okay, let's do another one. This time, can I just multiply it by an I? Don't write this down, just watch. So if we do the same thing that I did last time, that on the bottom I would have, you have to distribute it, so that would be 3I minus 2I squared, which, yes, this one turns out to be gone, but there's still an I on that 3, so that's not going to work. So what can I multiply this by to get this to be able to get rid of the i's out of the denominator? Well, I just spent all that time at the beginning of this video talking about conjugates. So, and we know conjugates, whenever you multiply them, the i's go away. So that's exactly what we're going to do here. We're going to multiply it, the top and the bottom, by the conjugate of the bottom, the denominator. So this will be 3 plus 2i. 3 plus 2i. Okay, so I'm going to go ahead and just do the top first. So I'm going to distribute that 1. So I would get 3 plus 2i. Not too bad, right? Then I'm going to distribute. These are both binomials, so you have to FOIL or distribute. So 3 times 3 would give me 9. 3 times 2i would give me positive 6i. Then distribute the other one. Negative 2i times 3 would be negative 6i. And then negative 2i times positive 2i would be negative 4i squared. Okay, there's a few things to clean up here. So we can cross off this middle, right? Because positive 6i and negative 6i that becomes 0. And then negative 4i squared is positive 4. Okay, so now we can clean it up. The top stays the same, 3 plus 2i, because you cannot combine those. They're not like terms. But the bottom, 9 plus 4, would give me 13. Okay, so the very last thing you need to check is if all three numbers, if you can simplify them or reduce them, whatever you like to say. Okay, is there any number that I can divide 3, 2, and 13 by? The answer is no, so you are done. So that's all you can do. That's simplified. There's no i's in the bottom. You're finished. Let's do another one. So letter C. So this would be, we're going to have to, since there's a binomial in the bottom, we're going to have to multiply by the conjugate again. So this would be 5 plus I. Okay, let's go ahead and distribute that 2. So I would have 10 plus 2i. Then do the denominator, distribute the 5. So that'd be 25 plus 5i. Distribute the negative I. So that would be negative 5i minus I squared. Okay, let's clean it up. That cancels. Negative I squared is like negative times negative 1, which becomes positive 1. So then I would have 10 plus 2i on top, because I can't combine those. And then what would that be, 26 on the bottom? Okay, let's check it. Is there any number that I can reduce all three of those numbers by? The answer is yes. You can divide all of them by 2, right? So this would become a 5, this would become a 1, and the bottom would be 13. So you get 5 plus, and you can write 1i, I'm just going to write I. 5 plus I over 13. Can you combine anything? No. Can you simplify anything? No. Are there any i's left in the denominator? No. So you are finished. Okay, letter D. This one's a little bit trickier, but not too bad. So we got to multiply it by the conjugate. Again, this time we have to distribute a lot. So I'm go slow so you don't make any mistakes. I like to color code, it helps me. So distribute that 2. So that would give me 14 plus 8i. Let's distribute that 2i. So this would be what? Positive 14i plus 8i squared. Distribute the bottom. So 7 times 7 is 49. 7 times positive 4i would be positive 28i. And then distribute that negative 4i. So that would be negative 28i and negative 16i squared. All right, so we've got a lot to clean up. Let's clean up what I do. It doesn't matter the order when you clean stuff up. I just always like to cancel those out first. It just makes me happy that I don't have to deal with that. Okay, so on the bottom in the yellow, so negative 16i squared, I know that becomes positive 16. And then on top, the positive 8i squared, that's going to become negative 8. All right, so now let's put it all together. So I have on top, looks like I combine my 14 and my negative 8, and then the 2 i's in the middle. So 14 and negative 8 would give me 6, and then positive 8i plus 14i is positive 22i. Okay, so, and notice that I wrote the real number first and this I number, the imaginary number, second. That's kind of math etiquette. I would not count it wrong on your test or quiz if you did not do that, but it's kind of something, a good habit to get used to because that's just what math etiquette is. Okay, and then clean up the bottom. Looks like all there's left to do is 49 and 16. What would that be? 65, I think. Okay, so 65. Can you reduce all of those by something? I don't think so. Are there any i's left in the denominator? No, so you are finished. Okay, 2 more. Actually, 3 more, I'm sorry. Okay, back to the monomials. So this one's a little different. Now we have 4 over 2i. There's a few different ways to look at this, but what I suggest doing is just multiply it by the same thing that's in the denominator. So that's what you do when there's only one term. If it's a 2-term thing, so a binomial, you have to multiply by the conjugate, but if it's just 1 term, multiply by this whatever the denominator is. But remember, what you do to the bottom, you must do to the top. So this would become 8i over 4i squared, which we know 4i squared is negative 4. So I have 8i over negative 4. Are you done? And the answer is no, because you can reduce. So 8 over 4, you can divide both of those by 4. So this would become, what would that be? Sorry, not negative 2. 2 over negative 1. So you could have a couple different ways you could write this. You could write it as 2i over negative 1, which is perfectly fine, or just negative 2i. Okay, let's go to the next one. It's kind of a similar problem. So let's go ahead and multiply this by what's in the bottom, because there's only one term. So by negative 8i. Looks like we need to distribute the top, so that would be negative 64i, and then positive 24i squared. Okay, and then the bottom would be what? Negative 64i squared. Clean it up. This becomes negative 24. This becomes positive 64. Okay, so what can we divide all of those by? Looks like 8. Oh, I made an error. You probably already saw it. Okay, let me back up here. So on the bottom, whenever I multiply that, negative 8i times negative 8i would be positive 64i squared. There we go. And then whenever you simplify it, it becomes negative 64. Okay, I thought I was doing something wrong. There it goes. Okay, so you have some options. Since all of them are negative, I'm going to reduce them all by a negative just to get rid of them because I don't want to deal with negatives if I don't have to. So I'm going to divide all three of these terms, so this, this, and this, by -8 because you can. So this would become positive 8i, this would become positive 3, and this would become positive 8. So whenever you put it all together, it would be 8i plus 3 over 8. And then I kind of broke my rule. We need to kind of flip-flop these around for the math etiquette, and it would be 3 plus 8i over 8. Okay? So that's how you do that problem. You can't simplify it any further, and there's no i's in the denominator. All right, last one. If you want to pause the video, try it by yourself, do it. So you have to multiply by the conjugate. So I'm going to go ahead and do that. 3 first, so that would be 24 minus 15i. This would be positive 40i minus 25i squared. This would be 64 minus 40i, and then positive 40i minus 25i squared. Okay, clean it up. Middle cancels here. This becomes positive 25. This becomes positive 25. Yeah, I think that's all we can clean up, so now we just have to put it together. So on top, when you add the real numbers, 24 plus 25 would be 49, I believe. And then negative 15 plus I plus 40i would be positive, what would that be? I think 25i. Then the bottom, 64 plus 25 would be 89. Okay, can you reduce all three of those by something? Nope, I don't think so. So there is your answer. All right, that is it. Thanks for watching. Have a great rest of your day.